Hey everyone, I am Bhagilakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about applications of Laplace transform to differential equations. This belong to Laplace transforms. So the application, before going to that, we want to know two formulas. If L of f of t equal to f of s, then L of f y dash of t equal to s into L of y minus y of 0, and another one is L of y double dash of t equal to s squared L of y minus s into y of 0 minus y dash of 0. Based on these two formulas, we are going to apply in differential equation, and we are going to get the conclusion based on this. First, we can go for this one example sum. Solve the differential equation using Laplace transforms y double dash plus 4y dash plus 4y equal to e power minus t, given that y of 0 equal to y of 0 equal to 0 and y dash of 0 equal to 0. So first we can write the given quadratic equation and taking the Laplace on both sides. So L of this term and L of take Laplace on both sides. So after this we can separate the functions. So L of y double dash plus 4 into L of y dash plus 4 into L of y, and also we know the formula L of e power minus t equal to 1 divided by s plus 1, and another one is L of y double dash. So L of y double dash, based on this the formula we are going to apply, plus 4 into L of y dash. So that L of y dash formula also we are applying here, and plus 4 L of y, which is equal to 1 divided by s plus 1. After this we can apply the values of y of 0 equal to 0 and y dash of 0 equal to 0. So these two values we can apply now, and instead of these two terms, and based on this y of 0, y dash of 0 is 0 and 0, and here also there is y of 0 equal to 0. So based on this, these values are 0 means the remaining we can collect and get right. So all the terms having the L of y, so we collect all the L of y, we got the one quadratic equation. So try to get the factorize these quadratic equation, we got s plus 2 the whole square. So after this, and keep L of y in the left hand side, remaining in the right side. So after this we got this, we can take this one to the denominator, and we got the multiplicative term. So it is based, for this multiplicative term we can apply for the partial fraction. So this left hand side L, take it to the right side, and it is having the format of y equal to L inverse of 1 divided by s plus 1 into s plus 2 the whole square. So it is of the form of applying the partial fraction. So using partial fraction we can separate these conditions. So here three roots we are having. So a, b, c, three constants we are choosing, and one more s plus 1 equal to 0 means s equal to minus 1, and s plus 2 equal to 0 means s equal to minus 2, and one more we can choose easily, s equal to 0. And based on this, even s minus 2 equal to 0, we got the c value, s equal to minus 1, and s equal to minus 1 means a value we got it as 1, and s equal to 0 means we got the b value as 0 minus 1, and applying all the value here, and instead of a, b and c. After this we got the value of this Laplace. So after the Laplace transforms, and instead of this Laplace partial fraction, we can separate these two terms. So first term, this first term, and then second term, and then third term. So each and every term we can separate. First term is L inverse of 1 divided by s plus 1. So first it is based on that formula e power minus t. So directly we can replace this formula, and minus L inverse of 1 divided by s plus 2. So 1 divided by s plus 2, here a value is minus, here plus means here we can write it with my negative term. So here a value is 2. So we can write replacement for this formula is e power minus 2t. And one more, here it is not in, we can't write directly. First thing, this power 2 we want to reduce. So for this power 2, first work is s plus 2. So for this s plus 2 means just immediately we wrote e power minus 2t. So that write e power minus 2t into L inverse of this 1 divided by s square we can write. After this in the second step, we are applying the formula for L inverse of 1 by s square. So L inverse of 1 by s squared is t. This formula, if we applied, at last we got the conclusion for the third term is t into e power minus 2t. So this way we got the values of the quadratic equation of this Laplace transform. Thank you.